So let's do an example. Read Auto sales. Read Auto periodically has a special week-long sale. As part of the advertising campaign, Read runs one or more television commercials during the weekend preceding the sale. Data from a sample of 5 previous sales are shown below. So we're told that number of ads, I guess this is the first time they did it in the last 5 weeks, resulted in 14 cars being sold. Then they put out 3 ads, they sold 24. Then they put out 2 ads, 2 commercials, they sold 18 cars, and so on. Now, if you look at the PowerPoints, it will show you how to find the intercept and the slope for this question to actually put the best straight line through this data. I'm going to show you how to use Excel to do it right now. And so let's just do that. So let's go for data, and there you go, data analysis, and we're going to go to scroll to find regression. It's alphabetical order, so there you go, regression. So we have to figure out what our Y range is. Well, our Y range, we're looking at the number of TV ads and the number of cars sold. So the dependent variable, I would assume, is going to be the number of cars sold. So let's go for the dependent variable in here, Y, the number of cars sold. And then the independent variable, or the predictor variable, the way we can predict the number of cars being sold will be from the number of ads. And if you notice, I've included the label of the column, so I have to make sure labels is clicked right here. And the output range, I'm going to put it in cell E1, press OK, and I get a whole bunch of output. Now, the only bit of output that we're going to look at right now, as we move on, we'll look at some more, but right now we're going to look at these 2 things in here, the intercept and the slope. And because that's all we need to come up with the best fit regression line for this data. And so the best fit line, well, the line we want to fit is for Y hat. So that hat or circumflex means estimated. So the estimated value of Y, which is the dependent variable, is based on your intercept, B0, plus your slope, B1, times X, which is your predictor or independent variable. So that hat means estimated. So let's put in estimated, and Y, so it's the estimated Y, and Y is number of cars sold. So the estimated number of cars sold is equal to B0. Now B0 is the intercept, which is 10. So B0 is going to be 10 plus B1, which is the slope, and the slope is 5, times X. And what did we say X was? X was number of TV ads. So I'm going to just put ads, make it a bit easier for me. So we can use this as a predictive tool and say that the estimated number of cars sold is equal to 10 times, 10 plus 5 times the number of ads. So if, for example, we made 3 ads, I'll just put a 3 in here. So 3 ads, we would predict that we would sell 10 plus 3, or 5 times 3, which is 15. 10 plus 15 is 25. We estimate we're going to sell 25 cars. That's what we're predicting using our predictor line. Now, all this is well and good, but at no point have we figured out, does that data that we were given, should we be using a straight line to fit the data? We didn't do any analysis on it, which we should have done. And then after, now we've got this regression line, the best fit straight line for that data. We actually haven't done anything to try and figure out if that line actually matches the data pretty well. So there's things we should have done before this, i.e. check to see if this data really appears to fall approximately on a straight line. And secondly, once we've got our straight line, to actually figure out if that straight line fits the data fairly well. So I'm going to redo a slightly more complicated example. Well, it's just going to have more numbers in. and I'm going to run the checks on that example this time. And then if you want, you can come back and you can run the same checks on this one. This one only has a few numbers in it, so you can actually do it by hand if you want to, but I don't recommend that you really do it by hand.